Back. Now that you've got mean and standard deviation for your populations calculated, let's graph it so we can look at it visually. So first of all, just a tip here. Remember, in the lab resources folder, there's a document shared with you titled Analysis, Practice, Sample Data, Fun with Sheets, Mean, Standard Deviation, Scatter Graphs. That's a mouthful, but this is a more static reference that has some written instructions for you that you can refer back to after you've watched this video. But for right now, just play along with me. So the first thing that we're going to do is we're going to reorient some of this data so that it's in a format that Google Sheets can work with easily, and it'll make it easy for us to get what we want represented properly. So I'm going to put cashew here, peanut here across the top. Then I'm going to type in my mean values. 1815, great year. 1366, there we go. And see what happened right there. I'm just going to fix that because it looks ugly. So there we go. Consistent decimal placing even here. So I'm going to go ahead and highlight those four things, insert a chart, and it can already read my mind and know that I want a column chart. If it doesn't, chart type here. This drop down will allow you to adjust how to do it. Just a little tip here, if you haven't done a graph lately, this is a new format. So when Google gives you the option, elect to do this style, the new one. Don't revert to the old method, otherwise this video is just going to confuse you. Okay, so I've got my graph here, and that's all well and good. You definitely want to have two different colors for the different series, and it should be labeled cashew and peanut. You're going to want to check this box, use row 9 as headers. That's going to make sure that the graph knows that this is the cashew group and this is the peanut group, because it'll use those as labels here up top. Okay, now let's shrink this a little bit, make some skinny bars. Now let me show you a second version here. You don't need to actually make a second graph, but you'll see why I did it in a second. So I'm just going to insert another version of the chart, and this is what you're going to need to do. So here's the chart. I've already checked the things I want. I'm happy with the bars. The bars are different colors. What we want to do is, this just showing us the mean values, right? We've got this other population statistic that we also want to present on the graph. The way that we represent standard deviation on the graph is with something called error bars. So you got to go over here to customize. Under series, you can turn on this box error bars. That's immediately going to put up these lines with little hats on them that go above and below your mean values. These are used, just generally speaking, an error bar is a way of representing variation in a set of data. Sound familiar? That's what standard deviation measures. Now, other things can be used to represent the error bars. So you could use error bars, for example, to show your max value and the min value in your population. You could show 75th percentile and 25th percentile. Confidence intervals. There's all kinds of different statistics that can be plugged into determining the size of these error bars. Today, we're using standard deviation. So here's how it's going to work. My standard deviation is specific to my population. Each column in the graph is considered a series, a data series by Google. That's what we call it. So in this drop down, I'm going to get off of all series, and I just want to edit cashews for the moment. I look over here, cashews had the standard deviation 1374. I've checked error bars. I need to get off percentages. I don't want 10% of my mean. I want a constant value, and that constant value is going to be, I'll type it in, 1374. Immediately plugs in that the magnitude of this is 1,374 up. In other words, our mean value plus one standard deviation. The lower error bar is showing us the mean value minus the standard deviation. So if we look at this range from here to here, that's 68% of the population of all the cashews, if we were to measure a bunch more based off of these three values and how variable they are. Okay, I'm going to do the exact same thing for peanuts. I'm going to go on error bars, make sure that's checked. I want constant error bars, 735. Now, get that on there. Great. I checked data label on accident there. I don't really need to have that data label there. It's kind of just busy. Okay. Then, of course, final piece of the puzzle here is we can go in here and edit all of the other kind of presentation things under chart axis and titles. So here I can select chart title, and I'm going to give it a descriptive title. You can come up with your own creative descriptive title. I'm going to do, here's an important one, chart subtitle. And the subtitle, a great thing to include is tell the viewer of your graph, where did you get these error bar sizes from? as I mentioned before, error bars just show variation, but which variation you're representing. Is it the range? Is it the percentiles? Is it 10%? Is it confidence? In this case, it's standard deviation. So put that on your graph. Error bars indicate plus or minus. You can hold down Shift, Option, and equals if you're a Mac user. One standard deviation. And that's a nice little subtext below so that we know what we're looking at there. Anyway, you can go in here and you can edit the vertical axis and horizontal axis title so you have labels everywhere. We've already got the legend displaying. That's here. If it wasn't turned on for some reason, you can make sure it was turned on here. None would turn it off, but we do want it, so keep it on. There, you can move it around potentially. But one thing to note here is look how different these two graphs look. All of a sudden, this looks like a massive difference for cashew. Wow, so much more energy. Okay, come over here, back to reality. Yeah, it does have more energy, but also look at how inconsistent the individual cashews were. We have the lowest individual and the highest individual all in this group. So the difference between these two is actually not so significant when we take into consideration how variable our data was. Basically, it suggests it's quite unreliable for both groups. All right, go ahead and now do your graph. Remember, if this video moved too fast for you, you can check out the exemplar, and it actually has a live sheet that you can go in and check. You can click on the things itself to look and see and follow the directions there. It's down here on the graphing groups with bar graphs tab. All right, that's it. Third video done for. Almost done.